One question that comes up in the scratch and dig classes a lot is what about reflective or non-transmissive parts? Are you allowed to do an inspection of a reflective or non-transmissive part using MilPerf 13830? And the answer is yes. NXC of MilPerf 13830 allows a reflective evaluation, and the ANSI OP1002 has the reflected test method, which is based on the same section. So the way that would work is you would take your comparison, your part that you're interested in measuring, and I don't have an inspection box here, but let's just pretend I'm inside an inspection box and the light's coming down from above. And I can go ahead and scan that part and see if it has any imperfections on it. This particular part is a silicon carbide flat. It's specified to 4020. And I would go ahead and find, so I've got a little scratch here that I can just barely see. So I would take the comparison standard that matches the specification. In this case it would be the number 40 scratch. And I would compare it visually. Now you'll notice that this is a transmissive comparison standard. That's according to the rules. You're not allowed to use reflective comparison standards to evaluate a part, even if it's reflective. You always compare the brightness of the scratch on the reflective part with the brightness of the flat in the transmissive part. The only difference is, instead of measuring it in transmission mode, I would look at it in reflection mode. So you look at the scratch that you're evaluating and the comparison standard in exactly the same orientation. And then you tilt it to maximize the brightness of each. So I could visually see that, okay, so there's my highest brightness response. I can see that number 40 scratch real well. And I tilt the part that I'm looking at and get the maximum brightness there, and I can see it's way less than the number 40 scratch, so it's probably fine. So that's how you would do it visually. If you have a Savvy inspector, it's also pretty easy to do. What you would do is you would take the part, load it onto the Savvy inspector, set focus, select a calibration file. In this case I'll be using the ANSI Army 314 file, which is the most recent calibration file. And you can see we can see the silicon carbide flat just fine. And in this particular case, maybe I'd scan around the part just to see if there's any imperfections that maybe I missed visually. In this case, there's really not much going on. A little bit of dust. And there's one nice scratch. That's the scratch that I was looking at visually before. So I can determine whether or not the scratch is a pass or fail. Well, first of all, I can tell right away that the scratch is a number 10. In the software, it's always showing you exactly what the grade is of whatever imperfection is in the little green 1 millimeter square box. So we know that the scratch is a number 10. I might worry about the length, so maybe I want to go ahead and measure how long it is to determine whether or not it would cause the part to be a problem with accumulation. So I would go ahead and left click and right click the mouse. The right click places the indicator for the scratch length, and the right click zeroes the encoder. And then I can just translate the part until I get the other end of the scratch at my little green dot. And I can see that it's about a 22 millimeter long scratch. So I've got a number 10 that's 22 millimeters long. And that would be how I would do that evaluation. If I wanted to save the data, of course, I'd want to create an inspection file, and I can dump the screenshots directly into the inspection file. But if all I'm doing is just trying to find out, does the part pass or fail, that's all there is to it. Thanks.